Here is the division of a section that I'm using in this presentation. It is deviating a bit from the sections that were written in the book. I already explained it. The last section we'll only do in the next meeting. The first section we in fact already did. So now we can turn to the second, and we will not read it, we will see when we come. We go now to the second section, and that is, I already described a bit that intuition of psychologists. We'll develop further on it. It will lead to a very good idea. I'm explaining it slowly today, but here we go. Assume you observe some preference of some person, and the person is indifferent between $1 for sure or 0.10 probability of 100. Quite risk averse, but it happens. And imagine similarly you observe indifference as written here. Each time a sure amount of money is equivalent to a probability of getting 100. For instance, $81 is equally good as a 0.9 probability of getting 100. Imagine you have this data set, you want to interpret, analyze it. Well, here is a figure that this is just capturing the data, no interpretation to it. What I do here on the x-axis, I put money amounts, and for each money amount, I indicate the probability at 100 that is equivalent to it. For instance, if we look here, this money amount is $9, the 0.3 probability of 100 is equivalent. So that data point corresponds with this figure. So these are just the 5 data points that we have, a way to store the information, nothing more, no interpretation. I can just as well depict it a bit differently. I can rotate left and flip horizontally the figure. I get the figure resulting here. Here now on the x-axis, we see now probabilities I put there. Now for every probability, I indicate the money amount is equally good as that probability of getting 100. For instance, a 0.3 probability of getting 100 is equally good as $9, so that's the second indifference here. So again, this is just capturing the 5 data points, no interpretation attached to it. Now, economists, they like to analyze the data, and they like to use expected utility to do so. So let us play their game and see what it brings. First, in the first indifference, they say the expected utility, this is just utility of $1. We take dollar as money amount now. It is equal to 0.10 times utility 100 plus 0.9 times utility of 0. Expect utility of this right prospect here in figure A. We do the usual normalization. The best outcome going on here is 100 versus 0. Utility 1 at 100, 0 at 0. It means that this expected utility is 0.10. Second indifference here, utility of 9 is 0.3 times utility of 100 is 0.3. Well, you've seen that already from standard gamma mathematics of this kind. A general formula, whenever I write alpha and p, what I think is alpha is the money amount, and p is the probability of 100 that is equivalent. So that's the general notation that I'm using here. Then economists say, if alpha is equally good as p probability of getting 100, utility of alpha is p. That was just standard gamma, we've already seen it. Now, with that general formula, economists look at the figure below and they really like it. They say, wait a minute, in this figure, for every money amount, we take the gambling equivalent probability, but that is just utility. So this is in fact the curve of the utility function, how much people like money. And this person is non-linear, deviating from the diagonal, deviating from expected value. It is because the person has non-linear happiness of the utility of money. Utility function of money is non-linear. That explains the deviation from expected utility. Economists are really happy with this figure. They like it much. Well, psychologists had different views. They were not happy with it. And psychologists say, well, we have the feeling risk attitude has more to do with probability than with money. So what economists do with money, we think we better do it with probability. So if we depict here what economists do, if they evaluate that prospect, they say, take the expected utility, they say the deviation from linearity, we put it through a non-linear utility function of money. That's what's going on here. Psychologists don't like it. They say there is deviation from expected value, there is non-linearity, but we think it's more promising to capture that by a nonlinear function operating on the probabilities. We think how people feel about probabilities has more to do with risk attitude than how people feel about money. So that's this psychological intuition, which is process-based, not directly real preference. Economists don't like it so much, but psychologists do, and I think here it was good that the psychologists insisted on it. You can imagine combining the two. First, properties of W, of course, weight probability 0 has weight 0. probability 1, we can normalize weight 1. W is increasing, the more probability, more weight, of course. Okay, then the combination, it may make sense to combine the two together and take a formula like this. And surely in the later parts of this course, we will be looking at it much. But for now, for simplicity, when I analyze the idea of the psychologist, I focus on the novelty of the W function. To keep things simple, I assume utility linear, utility of money. Effect for moderate amounts of money, as we see it here. This is a reasonable assumption. And later we will do the general, but for simplicity, to focus on the novelty, when I discuss psychologists, I take linear money for now. Now, with that, let's go back and see the data, what do psychologists think. So psychologists, they see the first indifference and they analyze it differently, and they already did from the beginning, since the 1950s. They say, well, probability 1, you get with probability 1, you get here $1. So the weight of 1 is 1. So the value, according to our theory of this, is just 1 times 1, it is 1. And the value of this theory is 0.10 times 100 plus something 0. I don't write the 0 term. So psychologists say this is a better formula to capture what is going on here, the indifference here. The second indifference, the way they like to write it, is, the value of this, according to theory, is just 9, 1 times 9. The value of this is the W of 0.3 times 100. So this is a good formula, they like it more. In general, with general alpha and P, if alpha for sure is equal to P probability of 100, the value of this is 1 times alpha as alpha. The value is, this is WP times 100. Psychologists like this general formula. But if you like this general formula, you will like this figure. Because psychologists look at this figure and they say, wait a minute, for every probability we're writing alpha, that is, for every probability we're writing WP times 100. That means that this is the graph of the W function. Well, multiplied by 100, but you can always transform, renormalize. Anyway, all the curvature here, you can see what is going on. So psychologists say this is a good formula. And here, this person is deviating from expected value maximization, deviating from linearity. It is how he feels about probability, not about money. So this figure is better capturing what's going on than that figure. Same economists, we think they're barking up the wrong tree. They're putting it in the wrong dimension. Feeling about probability, not feeling about money. That is what they like. And then with that, we extend the formula, try to develop a general theory. I will explain the first attempt of that theory. It was not very successful, but I'm going to discuss it in the next recording.